Join us today for this Ideas Technology Whiteboard session. Today, we'll be discussing the latest updates and information regarding hybrid multi-cloud and data center strategy, including Red Hat's build once, deploy anywhere strategy. Hello, my name is Keith Parks. I am the CEO of IDS. The function of these whiteboard sessions is to educate and empower you with up-to-date information, technology, solution, data. I'm excited about today's whiteboard session, hybrid multi-cloud and data center strategy, and Red Hat's build once, deploy anywhere strategy has been a huge area of interest from our nationwide client base. Sponsoring today's event is MAPSYS. DJ Singley, Executive Director of Data Center Solutions with MAPSYS, will provide the latest information on hybrid multi-cloud and data center strategy solutions. Okay, first, before we get started, let's just do a little bit of housekeeping for today's event. First off, this webinar will be available on demand. You'll receive an email with the link to access the presentation. Today's event is interactive. In an effort to encourage participation and to add some excitement, we've added a little competition. We will ask 4 questions during the presentation based on the information we're discussing. We'll be using the chat feature to ask the 4 questions. Please take a second to locate the chat box so you can see the questions. For the first right answer for each question, someone will win a $50 e-gift card. Remember, first right answer wins. At the end of the presentation, we will have a Q&A session. You may ask questions at any time through the chat or the Q&A window. Now I'm going to introduce DJ Singley for today's presentation on hybrid multi-cloud and data center strategy, including Red Hat's build once, deploy anywhere strategy. DJ, take it away.
Hello, folks. My name is DJ Singley. I am the MAPSYS Executive Director of Enterprise Architecture. Wow, that is a big mouthful, isn't it? So I work for MAPSYS. MAPSYS is a nationwide technology consulting firm. We sell hardware, software, services, and staffing. And I think we do a great job of all those things, of course. And I am the Executive Director of Enterprise Architecture there. And that just means I am a big geek, just like you guys on the phone here, you ladies and men on the phone here. So as a geek, I've been thinking about something lately, and that something is this concept of hybrid multi-cloud for storage. I feel like it's something I'm seeing a lot more in the marketplace, and customers are really wanting to understand how best to leverage this type of an idea. Now, also, this concept, I thought, wow, there's going to be like 6 people in the entire Americas that might be interested in talking about this right now, and at the end of 2020 with COVID here and everything. So when we planned this webinar, I was thinking we were not going to have quite the turnout that it looks like we're having. So I'm excited about that. Looks like this is a concept on more and more of your minds. So that's great. That's really great. So during this webinar, I'd like to sort of go over, 3 questions, right? So the first one is, what is it? What is this storage for hybrid multi-cloud? What is it? And then, how did we get here? So with that, why do we do it? Why? What are the reasons, the business reasons that we do it? What is the return of investment on this type of a strategy, et cetera, et cetera. And then finally, after we get that housekeeping stuff really, put away, we're going to learn how to do it. And also, what kind of products can I use to do this? Can I reuse my existing infrastructure? Can I reuse my existing cloud vendors? And that kind of thing. And the answer is all good, and we'll talk about that when we get there. So thanks so much for joining us today. Let's take a look and explore storage for hybrid multi-cloud. So the first thing I sort of alluded to already was that some customers are sort of already doing this, right? They're trying this hybrid multi-cloud approach, but not because they want to, not because it initially made their lives easier. It was because it was thrust upon them by the business. The business needed a certain solution, and it worked in a certain way, and now they have to support it. So with that, we find right now, about 95% of businesses are already doing a mix of clouds. So that's the multi-cloud portion, right? So maybe there's Azure and AWS and Alibaba and IBM and Google Cloud, the 5 big ones. Pick a couple of them, right? You're probably already doing business with a couple of clouds, maybe even some smaller clouds out there that are much less well known. All right, and of that, right, about 67% of folks have more than one public cloud provider. All right, so 2/3 of people out there are sitting there with more than one cloud. Now, that means those folks have to know the cloud interfaces for not only the computing side, both server and serverless architectures, but also all the storage, the myriad of storage that you can provision in these different clouds, as well as most likely keeping track of all of the storage infrastructure that seems to be sitting on their floor today right next to their office or their desk, right? That storage infrastructure being your on-premise storage that you never seem to be able to get rid of. Or maybe it's the more critical aspect of your deployment. So as time moves on, we're going to see much more of this concept of multi-cloud, the multi-cloud aspect, meaning more than one cloud provider is providing services for the business. And the hybrid part is, well, you have to manage it all, not only the multi-cloud, but also the on-prem storage. And there's got to be a way of making this easier and better and whatnot. And maybe even getting other parts of your organization, such as your development or arms or whatnot, or the development arms of the software providers you do buy software from, to play nicer in a multi-cloud type of an environment. And that leads me to this idea of build it once, deploy it anywhere. So the brief history goes like this. Way back when when blah blah blah, we had Linux, and then we went to Jap. No, I'm not gonna go over the exact brief history of all this stuff. But we had an idea of external storage out there, block storage. We connected to it through some protocol, iSCSI, whatever SAS or fiber channel, whatnot. And we consumed that storage and had various performance tiers and pain in the butt, and it was also exciting. And now we're at this new stage of architectures where we have these things called containers. And how do I, as a manager of this stuff for the enterprise, how do I manage my traditional infrastructure along with all this new stuff that's coming online with containers and this new thing called Kubernetes, which manages these containers, right? And this Linux operating system that they most typically run on. Okay, and that's the crux of the matter here is you certainly have most folks certainly have a large amount of traditional workloads out there on-prem and in the cloud that are working just fine. But as time moves on, you will definitely be deploying new pieces of software, and a lot of that new software is all written in this container type of fashion. Why? Well, it's very easy for a developer to understand how to write the software, put it in a container, and then manage it with containers. So it's easy for them to do this, and it will be very easy for the folks on the phone here and managers of this type of a scheme to deploy it and manage it as well. And that's where we are sort of today with this idea of this Red Hat OpenShift Container Platform, OCP. So, I have a couple of servers listed there. This scales from the very, very largest IBM mainframes to power systems, and which is, what I'll say, the last surviving Unix OS out there. And then, of course, the x86s and other platforms, diminished platforms from other vendors as well, such as, HP and whatnot. So you're going to be managing infrastructure between these three locales, the private, the public, and even the edge spaces as well. We could talk a lot about edge computing here and edge storage, especially as the AI revolution comes into play here. And if any of the folks are on the phone here and heard my last webinar about AI for manufacturing, you can kind of understand a little bit better about how that might actually come into play. So so anyway, that's where we were, where we are today, and how do we do this? How do we get to the next chapter and continue to build an infrastructure that's easy to manage, that's cost effective, and that can leverage these different cloud infrastructures, no matter what they are. And lastly, I want to introduce you to this concept of cybersecurity. Oh, I just cringe so much when I even hear that word. I know the folks in the phone here and the webinar are probably cringing as well. And I don't mean to say lastly, I really mean to say the cherry on top of the reasons to do a hybrid multi-cloud approach is security. It really is. And as you move forward through your business, you're going to end up with more and more threat vectors and more opportunities for threats to adversely affect your business. And a hybrid multi-cloud approach may be just the ticket to avoid substantial financial loss, but also give you those check marks on those business needs that you have, those business need sheets that say, yes, I need to have a DR site. Yes, I need to have backups everywhere. Yes, I need to have air-gapped backups. What air-gapped? Why do I need an air-gapped backup, Mr. Security Officer? Well, let me tell you, son. And then he'll just go into, or she'll just go into, all the various reasons why you need it. But how do you do that? Well, that is something I think that hybrid multi-cloud can absolutely help you with. This idea of an air-gapped data copy of your data that is unchangeable, but is also discoverable, meaning you can find it when you need it, and you can actually restore your data fast enough, fast enough that everyone still has their jobs, right? So, very important concept. We'll talk a little bit more, I think, later how to accomplish this type of a goal with the tools that we have. So I know what some folks are thinking on the phone too. Also, is like, listen, I have Azure storage, I have AWS storage, I have IBM cloud storage. I have to use it. It's just what I have. I mean, it's all a pain in the butt, but it's just what I have. I don't understand how hybrid multi-cloud is going to change that. Is there a way I could use all this storage, sort of under a single pane of glass from my home base, maybe even my home base storage, my on-premise storage? And the answer is, yeah, there is. There is a way of doing it. And that's a way of modernizing the storage you already have. That includes the storage that's currently on-premise. And that really says preserving assets that you've already paid for, just modernizing them in their capabilities. So this is a good way to simplify that journey to this hybrid cloud model. And hybrid cloud is something we're all going to continue to have to wrestle with and struggle with as time moves on. All right, let's talk about the pieces and parts we need to get this done, and how do we do it? So the first piece of this is really the concept of storage as a software-defined storage stack, SDS, software-defined storage. So I know a lot of you out there also are probably thinking of, hey, I've seen this before, right? It's in the Gartner Magic Quadrant, and they talk about software-defined storage as sort of the next revolution that's sort of already come and gone, to be quite frank. Everything is software-defined these days. All these storage vendors and storage platforms are software-defined. Some were just not sold as a software-defined offering. And there's probably a lot of tears about that, because maybe they should be. So the software-defined infrastructure, though, does a lot of things for you. The agility it gives you to move data between data centers or clouds, which is really, really important. That's like half the reason of doing hybrid multi-cloud. It's the ability to bridge into new technologies. I already talked about traditional architecture and these new containerized architecture with Kubernetes. If you don't really understand what Kubernetes are yet, or Docker or any of that stuff is yet, it's fine. You will get some learning as it gets into your infrastructure here in very short order. I promise you that. And you will want to understand how to bridge from traditional to the new technologies. And then the cloud portion of this piece, right, where you adopt the capabilities of the storage that can be deployed across all your clouds. And that's your hybrid part, your hybrid multi-cloud part. But gee, wouldn't it be nice though, if now I got all these fantastic things that I can do between clouds and on-prem, wouldn't it be nice though if I could continue to use all of my advanced abilities that I know and love on premise, and maybe even some of the advanced abilities I know and love in the cloud, right? Such as encryption, encrypt your data, make sure that no one's going to walk off with a disk drive and take all of the social security numbers and credit cards you have sitting on there. And then, of course, the data reduction part of those advanced functions, right? The dedupe and the compression and the pattern matching and all that jazz that we love, because it takes our storage footprint cost down so much. So that's these 5 things I think are really critical to understanding, sort of how we're going to do this. So when you're looking at a piece of storage for this new containerized world, whether it's Red Hat Open Container Platform, whether it's bare Kubernetes, whether it's running on Red Hat at all, or Ubuntu, or whatever Linux you happen to have or support, and chances are you're going to be made to support more than one flavor of Linux in time. As long as you're running containers, as long as you're running Kubernetes, I should say, you will have the ability of running this thing called a container storage interface, a CSI. And that's this API that storage vendors will need to implement in their storage in order for the Kubernetes platform to talk to the storage, to do things like provision the storage and mount volumes and delete volumes and delete data sets. And that's an important concept. The CSI exists to give power back to the programmers, the folks that are creating these applications, right? To give them some more flexibility in how they design these applications. And that's why it's there. And I don't want anyone to forget that. That's really important. It's not there to make a storage administrator's job easier. It's there to make the programmer's job easier. But by making the programmer's job easier, it makes the application easier in general to live with and deploy and understand and do performance management on and all that stuff. So if you take nothing else out of this part, take this concept of a container storage interface, CSI. It's an API that storage vendors will need to use to support these new workloads. But it can go even another step farther, in that CSI can help you with this multi-cloud concept. Right? If you have your on-prem storage and your cloud storage and it supports CSI, you can move that container directly from your Kubernetes clusters, managed Kubernetes clusters, from an on-prem deployment to one of your clouds, and then move it from one of your clouds to another one of your clouds. Wouldn't that be something? Maybe you're just searching for the best price to run this workload, the best cost, or the lowest cost, I should say. Not just the best, not the highest cost, the lowest cost, right? So that is something that you now have enabled because of these new workloads and this new container interface. So keep that in mind. Let's move on. So I did talk a very small amount about simplifying the idea of simplifying or knowing the different storage interfaces at Azure and IBM Cloud and AWS and Alibaba or whatever. You're gonna have to be an expert. And okay, what was Glacier Storage? Oh yeah, that was AWS. Okay, I gotta know about that. Oh yeah, what I do at Azure? How do I provision the database and storage for the database? I forget. I don't remember what disk tier is that on? Oh gee, I don't remember. Well, that's the point. Is that you shouldn't have to deal with all this. You shouldn't have to be an absolute expert in all these clouds that you're going to be made to support. Wouldn't it be nice if you could just remember one interface and one way of interacting with the technology that you want to use, whether it be in the cloud or on premise? And there is a way of doing that. And again, it's all enabled with storage, software-defined storage, right? And with that, you can do this. You can do these things. So what that means is that the software that runs your on-prem storage can run also in the cloud, and not just one cloud, but all the clouds. And they're not just sitting in little islands of storage. They could talk to each other through, this thing called the internet, or all the internets, right? Tell me what that movie's from, the internets. All right, write it in the comments below if you can remember. But anyway, so that's sort of an interesting concept, a really important concept, and I think that once you let that set in for a little bit, you're going to understand the value in that, right? You want to be able to see the same GUI, the same management interface, the same way you migrate storage across, whether that be traditional storage or these new containers, the same way going from any cloud to even on-prem. So now it all sort of looks alike, and it's easier for you to understand and continue to manage. And we can do that. One more thing to consider in modernizing the storage infrastructure you already have is this concept of operational resiliency. Deploying and automating and testing and replicating data can be tedious and expensive. And like most things we've discussed, the traditional implementations tend to lock you into a particular hardware vendor. But the right storage software foundation can help you implement the advanced things like 2 or 3 or 4 or 5 site replication. By the way, those sites are cloud or on-prem, right? Many clouds. And you can use the same APIs and procedures and automation methodologies that you come up with, regardless of your choice of hardware in the cloud or hardware on premise. So that's another real good idea, right? To implement when you're doing this hybrid multi-cloud thing. Another reason why you want to do it in the first place, and how you're going to do it. So think of storage as adding another layer of security, right? I think more and more customers out there are looking for encryption at rest schemes on their disks. And now again, that we're on-prem or off-prem in these clouds, now we have different encryption schemes all over the place. Where are my keys? How do I manage this? How do I unlock this? I don't remember. And the point is, when you don't remember and you have a security event and you're going to need to remember immediately to unlock that data and get it going and make sure that a hacker hasn't tampered with that data, you're going to want some operational resiliency, right? There's, to use a term from the previous slide, to help you do that. Okay, so interesting slide, I think, is that almost a quarter, or more than a quarter rather, of the folks on the phone here probably have a high likelihood of a recurring material breach over the next couple of years. And encryption, especially encryption that is that is standardized across all the clouds and on-prem, can very, very much help with that. So can those air-gapped copies that I talked about before. And both of those should be in software-defined storage multi-cloud scheme. So I think it would be a terrible idea to introduce these concept of a hybrid cloud and hybrid multi-cloud without talking about the latest hotness, the new hotness in the storage industry, right? Especially these two concepts of NVMe and storage class memory, right? You certainly don't want to take a look at your data center in 5 years from now and walk in there, your on-prem data center, and see a bunch of SAS disks sitting there. You won't even remember the protocol that was used back in the day when you bought the disk, right? You don't want to buy something that's already obsolete today just to hit this multi-cloud, hybrid multi-cloud object here and business case. You also want the best, highest performing, newest piece of kit out there. And two examples of that are this NVMe attachment, which is just specific to solid state disk drives and a better way of attaching them with much higher throughput and latency, lower latency rather. And then this idea of storage class memory, which provides even faster SSDs, which much higher write-ware levels. That is, enabled on some of these larger arrays. I shouldn't say larger arrays, but some of these faster, more advanced arrays that provide unbelievable storage performance jumps. That, to be quite honest, right now, most of my customers are, while they're eyeing the storage class memory space, they are certainly not investing in it right now. It's very expensive for these SSDs here, and both of these technologies are very, very good, and you're going to want to have at least the capability of deploying them in any on-prem infrastructure that you bring in. So that software-defined storage that we've been talking about, that software-defined storage, better not only help me or help administrators administer their cloud platforms, their multi-cloud platforms, but it better help me with the latest, fastest, new hotness for on-prem storage. And luckily, there are solutions out there that do that. So when looking for a hybrid multi-cloud platform, it better support the latest and greatest. So at this point, I think we come to a decision point. Do you, as an administrator, modernize and then stop? Right? Say, hey, I did pretty good. Got some new stuff in here. It's sort of software defined. I can, replicate 1 or 2 volumes up to a cloud provider. That's great. Or do you say, maybe I should be innovating more and using a true software defined storage platform that I could literally run the software in the cloud as well, host my workload in the cloud on the same software. Yeah, that's good. And also, protect my workload in the cloud and on-prem with the same software and the software-defined storage stack. So your choices that you make, I think, certainly have an impact on your hybrid multi-cloud future. If you don't make quite the right decision, you could be in sort of a bad place. But I also want to make the point that a lot of you may have a very, very fond storage vendor that you really like working with out there. And maybe a lot of you just don't care either. Whatever the cheapest disk and most performant disk is, you're just going to buy. And I understand that too. And wouldn't it be nice if a product was help you with that by helping you leverage current investments and future investments? That's another part of this. The future investments is important. Say storage vendor A has really nice disks today, really cheap disks today, but boy, 3 years later, storage vendor B has really nice disks now and they're cheaper. So maybe you want to make a switch. Wouldn't it be nice if the software-defined storage stack could help you do that? And yes, it is possible. We can do that. So with your software foundations, right, traditional infrastructure such as Windows, Linux, VMware, moving to the containers and Kubernetes type of infrastructure, the idea of being able to move data and workloads from data center to data center, from cloud to cloud, on-prem or in the cloud, the idea of reducing your data footprint size using data reduction techniques, and then protecting your data across all platforms. These are probably the four tenets of the software that you really should look for. I would add, of course, the fifth one being the new hotness, and I would word it exactly like that, the new hotness, just so you're able to utilize the latest and greatest in storage technology, whatever it happens to be. Today it's NVMe. Tomorrow it could be NVMe DVAB, right? Whatever that one might stand for, because we love alphabet soup here in this industry, right? But more importantly with that, as looking at it from a programmer's type of view, the consistent APIs across the storage platforms, right? And for your on-prem deployments and your cloud platform deployments. Now these programmers, whether they be programmers in their software development house that you hired to do your work, or your own in-house programmers, now they just need to know one stack of consistent APIs. And so where do we go from here? I want to spend a little bit of time putting a little finer point on this, because I think it might be lacking with some of the conversation we're kind of getting lost into now. And that is with this sort of homogeneous view of the world, most vendors are now coming up with ways of projecting their on-premises storage capabilities into the cloud, right? And I have a couple of vendors sitting here that most people should be familiar with, right? And that's great. That's great that all these vendors are doing that, right? Projecting their capabilities into the cloud. They should be. If they're not, they're going to be left behind in this multi-cloud universe that we now live in. The strategic challenge, though, is that these things are, again, tied to your choice of on-premises hardware, right? If you're currently using NetApp hardware, you train your people, you build your automation processes, and you set up your procedures around the approach used with NetApp hardware, for example. Then, if some new innovation in physical hardware drives you to, say, Pure Storage, you not only have to change what you are doing on premises, but also what you are doing in the hybrid multi-cloud that the old NetApp gear was connected to. So imagine if you were replicating data to the cloud using NetApp methods and had to switch to Pure methods. So you're going to have to learn new methods, methodologies, and new procedures, which is all pain, and it does cost real money. You have to switch your automation to new APIs and retrain everybody, re-replicate your data. And you're going to be incurring lots of new data egress charges from your favorite cloud vendor, which I'm sure at that point you'll have discovered what those charges are, and you're not going to be happy about them. No one ever is. Anyway, it's an age-old challenge that the hybrid multi-cloud just multiplies. So the storage choices that you make matter because of the cloud use cases. And here's sort of the cloud use cases that we can really hammer in on and highlight to make our point. The business continuity, which really is disaster recovery, right? Or highly available workloads. DevOps is probably not a lot is not on the top of everyone's mind, but it's going to be, especially as we rush more into this containerized, Kubernetized world that we're starting to live into now. The developers are going to have more say in how these applications are deployed, and you're going to ultimately want them to have more say. But with that, the idea of the security and air-gapped data copies and whatnot in the cloud or on-prem, that's a big deal, because with that, you'll be able to recover from disastrous cybersecurity snafus, kerfuffles, right? I love that word, kerfuffle. It's a funny word. It's important to understand that. I could probably give you a couple of horrifying stories from customers of ours that have experienced some data breaches, and they are absolutely horrifying. And with these type of technologies, you could mitigate that somewhat, or actually quite a lot. And then maybe not lastly, second to lastly, right, is this idea of workload migration, as you could hunt for the right place to put your workload between all of your public clouds and your on-premise locations. So which one's going to give you the best performance per dollar or euro or wherever you happen to be in the world to run that application? And if that economics of that changes because the pricing changes, you have the freedom then very easily of moving from one cloud to another cloud. There's no lock-in, and it doesn't matter what cloud you're on. So the hybrid multi-cloud, that's where we're going. The permanent state of operating infrastructure, both on-premises and in the public cloud. So I wanted to throw this slide in here, and there was not a great place to put it, I think, but I wanted to remind folks that one of the benefits of going to the cloud, this hybrid multi-cloud, is this idea of utilizing or buying what you need from a cloud vendor when you need it. So you're shifting some of this CapEx to an OpEx fashion. And that's very attractive to a lot of folks for a lot of different reasons and a lot of great reasons, right? Is hopefully you're going to be saving some money and you're not going to be overbuying an asset that's going to be sitting on your floor that may not be fully utilized, right? You're not going to get every single dollar out of those petabytes you have on floor unless it's 100% full. You're just not. But in the cloud, you can get your dollars worth because you are going to be provisioning only what you need and you're going to be paying for only what you need. So this is what we call our flexible consumption model as you look at deploying storage in the future, both on-prem and in the cloud. And another reason that you really want this idea of hybrid multi-cloud. So I know I've been talking a lot about this entire journey, what is a hybrid multi-cloud and why would you want to do a hybrid multi-cloud? And then finally, how do you do the hybrid multi-cloud to some extent here? But I haven't really told you how I like doing the hybrid multi-cloud because I have a certain piece of software-defined storage that I find to be one of the best, and it can be hardware agnostic. It could be using one of the other vendors that we talked about there, the HPs and the Pures of the world, and the EMCs, or its own storage as well. And it should probably come to no surprise to some of you that this software I'm talking about is the IBM Spectrum Virtualize software. It is a leader in the Gartner Magic Quadrant, and it allows you to do these 5 things very, very, very well. The agility portion is, look, folks, buy whatever disk you want. All right, in the clouds, you're going to be buying the cloud disk. You don't have a choice. You're going to buy whatever cloudy disk that Azure has or AWS has. You don't get to even see what it is. But on premise, buy what you want. Buy an Hitachi. Buy an IBM. Buy Oracle disk. Who buys Oracle disk? Don't buy Oracle disk. Buy your Dell EMC disk. Whatever it happens to be. You can use any of that. And you can move seamlessly between it as you retire and bring new disks online and retire old disk. And if you don't want any of that disk, you can buy IBM disk too. Whatever happens to be the most cost-effective and performance disk, just use it. But then when you're ready, you will be able to use the software, the Spectrum Virtualize software, to make the bridge from traditional workloads to the new workloads of the future, the container storage interfaces with OpenShift and Kubernetes and all this new stuff coming down the pipe. It's all there. Now, I suspect some of the other vendors may have some of that in the future, but it's all there today with the Spectrum Virtualize software. And more importantly, though, the hybrid multi-cloud piece is there too. You can go today, at least today, on these 2 clouds, on the IBM Cloud and AWS. I think Azure is like next week or like next month. It's really soon. And go into the app catalog and pick the IBM Spectrum Virtualize software and deploy it. And now you have a fully functioning Spectrum Virtualize instance in the cloud, and you pick whatever disk you want to back it with, whether it's Glacier disk. And, don't do that unless you really want to go slow, at AWS, or fast tier 0, tier -1 disk, super ultra fast NVMe SSDs. You can do all that, and you can tier internally to the Spectrum Virtualized software between the 2 types of disks, whether that's on premise with a Hitachi array or in the cloud with Azure or AWS. And then you can also use your data reduction between all of these different areas. Not only the data reduction in the cloud, so compression and dedupe in the cloud, but also on-prem. But not just with IBM disk. You can use this data reduction with NetApp disk and HP disk and Pure disk. And I know what some of you are saying is you're probably saying, well, yeah, those disks include the data reduction. Well, yeah, some of them do. Some of them you can't turn them off. Some of them are features that you have to buy as an add-on. But they all work a little differently, and they all have their various hiccups and peculiarities. Now they all work the same way with one data reduction scheme, and that's the Spectrum Virtualized data reduction scheme. And then very lastly, encryption. Same thing goes with encryption as data reduction. Encryption can be applied to all your cloud disk resources and all your on-prem disk resources, as well as all your third-party storage disk resources. The Pures and the NetApps of the world can all have the same type of encryption that is being presented to it with Spectrum Virtualize. It's like magic, but not. It's engineering, right? So pretty great. So here is a product called a SAN volume controller. The SAN volume controller is actually a piece of hardware that runs the IBM Spectrum Virtualize software. And there are 2 nodes right there you can see. And this SAN volume controller, I'll tell you guys, it's pretty great. It really is. This thing is what you would use for an on-premise deployment of Spectrum Virtualize. If you didn't want to have any disk, IBM disk behind it, you could just have some third-party vendor disks. But it's important to bring this up because I think a lot of the trade rags, Gartner and IDC, they're suggesting that organizations will be using a consumption-based OpEx model in the next several years. And one way to get there is using a SAN volume controller, or using Spectrum Virtualize on-premise and in the cloud to help you understand that. And the big reason, it's obvious why businesses are trying to get there, is that they're trying to reduce this budget risk. Budgets go up and down, and some are spent, some are not spent, and it's just a lot of risk as most companies go through their budgeting cycles. So IT managers in the data center can provide cloud-like flexibility and capacity always at the ready, without the risk or cost of paying for something that's not being used. And cloud-like pricing prevents service provider customers from carrying the cost of additional infrastructure, right? Buying more disks than you need. The necessary automation and metering is already being delivered by vendors. It is certainly something to watch closely as we continue talking about this stuff. So, SAN volume controller, pretty great. But we can go a couple steps further than that. There's an entire slew of systems from almost any price point that also run the IBM Spectrum Virtualize software. And because we're in 2020 now and almost everything is a flash disk, the whole family of systems is called the flash system family. So that means from the smallest sort of mid-range entry-level space of a flash system 5100 all the way through the very, very high-end flash system 9200. All of this is based on NVMe, by the way. But it can all also act as a SAN volume controller, act as a way to control third-party storage. And, of course, it runs the same software that you're going to run in your clouds, all of your clouds, whatever they happen to be. So if you take nothing else from this conversation, take this with you, and that is containerized workloads and Kubernetes, it's coming for you. And you're going to have to support this type of a workload in your environment. And these workloads can scale very nicely on the cloud and on-prem. And wouldn't it be nice to have a storage infrastructure that could handle both? So we're looking for a consistent platform for building and scaling containerized applications across all your environments. So as an example, the Red Hat OpenShift Container Platform offers a consistent enterprise Kubernetes platform for building and scaling containerized applications across the kinds of infrastructure that modern applications gravitate to, including, secure transaction processing systems like a big giant IBM mainframe or something, AI platforms, pick your choice of AI platform, and multiple public cloud vendors. So IBM has the concept of a cloud pak that includes other software that could be useful for building these types of infrastructures, these Kubernetes infrastructures. So you can build out the entire portfolio with a containerization methodology to give you the capabilities and developer servers, anything from WebSphere to Watson. And if that doesn't mean anything to you, it's fine. You could be other services as well. And in business automation things and things like blockchain. And blockchain is becoming more and more a thing lately. as time rolls on. It's going to revolutionize more and more things, and blockchain runs spectacular on a containerized solution. So these cloud packs are interesting. IBM offers the IBM Storage Suite for IBM Cloud Packs. This is a software-defined storage for hybrid multi-cloud containered environments. It's faster, it's more reliable, a way to modernize and move to the cloud. And it's the only offering that combines all these open source components with the IBM software titles that we talked about, like Spectrum Virtualize, to deliver the data resources for block, file, and object storage. So this is a strategic storage software foundation that connects containerized applications to their data, regardless of your choice in hardware suppliers or your choice of clouds, because you're going to be using multiple hardware suppliers depending on what you find most interesting to deploy on premise. You're going to be using different clouds depending on probably what's shoved down your neck, whether you like it or not. So why not wrap around all of this a platform, Spectrum Virtualize, IBM Spectrum Virtualize, that can manage all this? Spectrum Virtualize is the software foundation for your block storage. So one of the goals of offerings such as the Red Hat OpenShift Container Platform and IBM Cloud Packs and IBM Storage for Hybrid Multicloud, what we've been talking about today, is to make open source enterprise safe, to offer full stack solutions that are easily deployed, easily maintained, and that can be used both on premises and across multiple public clouds. And that's really the key to all of this. I think I've shown you today how to do that. And to learn more, I'd suggest a couple of things. Well, I suggest just going to YouTube and typing IBM Spectrum Virtualize and just learning some more. Right? Are there other software like this? I'll tell you, no, not really. I mean, all those other vendors I talked about have their own very locked in ways of getting you to the cloud and only using their stuff. They don't want you to use someone else's disks, because if you start doing it, you might just switch to their disk. IBM just almost doesn't care in some respects. Use whoever disk you want. Just use the IBM software, because it's going to be the best and easiest, and you can continue to buy whatever disk or thing you're looking for. The other option of learning more, of course, is have some more conversations with me. I enjoy doing this type of stuff. I really do. We have lots of customers out there doing very similar things, and they're very successful now with some of their deployments, and we're doing more and more of these cloud deployments every day. In fact, I could go into the Amazon AWS Marketplace right now, go into the catalog, pick Spectrum Virtualize. A couple of minutes later, it's deployed in couple of small instances, and then I back it with some storage, and I'm off to the races. It's really that simple. I can even attach my virtualized workloads at Amazon very easily right to it, and I'm all done after that. It's just a walk in the park. And when I sit back in my on-prem deployment, which is probably one of those machines I showed you earlier, right? The flash system 5100 and 7200, 9200. That's probably the easiest way to deploy it. It's all going to look the same, and it's all going to act the same and do the same thing. And that's the important thing. So thanks again for your time today, folks. I appreciate it. I'd love to give you a demo of some of this stuff, how it works. If you got some time later on, contemplate it, see what you think. You can always look me up at LinkedIn. My full first name is Daneyand. If you type in daneyand.com, DANEYAND, it'll go right to my LinkedIn page where you can connect with me and take a look at all the stuff that I'm posting up there and continue the conversation there or on the phone. Appreciate all your time today. Stay safe, everyone. We'll talk to you soon. So with that, I think we're going to do questions or whatnot. So I'm going to give it back to Keith. Thanks again. Bye-bye.